Hello and welcome to another video. In this video we are going to be talking about the slope of the tangent, which is going to help us find the instantaneous rate of change of a function. So let's get started. So let's revisit the slope of the tangent. This is a concept that we already covered in our first topic. But we do want to revisit it now that we have looked at limits, because now that we know what a limit is, we are going to use it. We are going to use the concept of a limit as well as the concept of the slope of the tangent to find the instantaneous rate of change of a function, okay? So let us recall that slope is the instantaneous rate of change, right? So the slope of the tangent is approximated by using the first principles formula. And this is the formula that we looked at in our first topic. Remember, f of a plus h minus f of a over h. So now we are going to be taking the limit as h approaches 0 of this formula so that we can find the instantaneous rate of change. Okay? So here, A, again, is the point where we want to find the slope of the tangent. So we have our formula, we know what the slope of the tangent is, we know what a limit is, so let's do this. Example 1, find the slope of the tangent of f of x equals to x cubed minus 3x squared plus 2x plus 1 at the point 2, 1. Okay. So what information do we have here? Well, we know that f of x is equal to x cubed minus 3x squared plus 2x plus 1, right? So we also want to know what the value of the function is when x is equal to 2, which from the point that we are given, we know is going to be equal to 1. So then the slope of the tangent, or m, is going to be equal to the limit as h approaches 0 of f of a plus h. A, in this case, is equal to 2, right? So 2 plus h minus f of 2 all over, not 2, but h. There we go. Okay, so this is going to be equal to the limit as h approaches 0 of 2 plus h cubed. So now we are going to apply the function to what we have here inside of the bracket, right? So that's 2 plus h cubed minus 3, 2 plus h squared plus 2, 2 plus h plus 1, and now we have to subtract f of 2. So minus 1. And of course, all of this over h. Okay, so right away, we can see that we cancel out those 1's, right? And now we have to expand all 3 of these terms, okay? In order to do that, we do have to recall our trinomial and binomial expansions, right? So for example, if we have a plus b cubed, this is going to be equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And so using 2 as a and h as b, this is going to be equal to 2 cubed, which is equal to 8, plus 3 times 2 squared times h plus 3 times 2 times h squared plus h cubed, which is going to be equal to 8, plus 3 times 2 squared is equal to 12, 12h, plus 3 times 2h squared is equal to 6h squared, plus h cubed. So let's write that over here. So this is going to be equal to the limit as h approaches 0 of 8 plus 12h plus 6h squared plus h cubed. And now we are also going to have to use our binomial formula to expand the rest of the terms. So now let us recall that a plus b squared is equal to a squared plus 2ab plus b squared. And so 2 plus h squared is going to be equal to 2 squared, or 4, plus 2 times h, or just simply 4h, plus h squared. So here we are going to have negative 3 times 4 plus 4h plus h squared. And now all we have to do is just expand that last term. So 2 times 2 is 4. So plus 4h, or sorry, so just 4 plus 4 and plus 2h. There we go. Okay, so that's the expression that we should be left with for now. Let's just simplify that middle term there as well to make sure that everything is expanded. So we're going to have 8 plus 12h plus 6h squared plus h cubed minus 12 minus 12h minus 3h squared plus 4 and plus 2h. There we go. All right. Okay, so now, and of course all of this over h. And now there's quite a few terms here that we can cancel out, right? We are going to have here positive 12h with a negative 12h. We are also going to have positive 8 with positive 4 with the negative 12. And that is it for now. Then we should be left with 6h squared plus h cubed. And then minus 3h squared. Of course, that's going to simplify with the 6h squared there as well. Those two are going to combine. And we should be left with the following expression. The limit as h approaches 0 of 2h plus 3h squared, after we combine the 6h squared with the negative 3h squared, plus h cubed all over h. And here, of course, now we are going to be able to factor out an h, and we are going to have 2 plus 3h plus h squared all over h. Those two h's are going to cancel out, and we are going to end up with the limit as h approaches 0 of 2 plus 3h plus h squared. And once we evaluate this limit, which we can now because we no longer have that h in the denominator, which would cause us to have division of 0, right? We do not divide by 0. So here we are going to have 2 plus 3 times 0 plus 0 squared, which is, of course, just 2. And so what does this tell us? It tells us that the slope at the point 2, 1 is 2. Or the instantaneous rate of change at 2, 1 is 2. The slope or instantaneous rate of change. Okay. All right, let's take a look at another example here. Example 2, find the slope of the tangent of f of x is equal to 1 over x at the point 2, 1/2. All right, so again, same process, right? We are just going to start by identifying the information that we are given, and we are going to start by writing out the first principles formula. So in this case, the function that we are given, f of x is equal to 1 over x, and we are at the point 2, 1/2. And this means that f of 2 is equal to 1/2, right? So again, let's rewrite our first principles formula. We are looking for the slope of the tangent at that point, and that's going to be equal to the limit as h approaches 0 of f of a plus h. A in this case is equal to 2, so 2 plus h minus f of 2 all over h. And so this is going to be equal to f of 2 plus h is equal to 1 over 2 plus h, and now minus f of 2, that's going to be equal to 1/2, and all of this over h. And so now here we might notice that we do have a complex fraction, and so what is the manipulation that we want to use? We want to find the common denominator between the two terms in the numerator, right? So let's do that. Here we are going to have the limit as h approaches 0, and now here we are just going to cross multiply. So we're going to multiply both the numerator and the denominator by 2 for the first fraction. So we're going to have 2 over 2 times 2 plus h, and then we are going to multiply both the numerator and the denominator for the second fraction by 2 plus h. So here we're going to have 2 plus h over 2 times 2 plus h, so that we can get that common denominator. And all of this, of course, over h. All right, so let's expand and simplify over here. All right, so still we are going to have the limit as h approaches 0 of 2 minus 2 minus h all over 2 times 2 plus h, which we can, of course, factor in as 4 plus 2h, or you can leave it as is, all over h. Okay, so now right away, the 2's cancel out, and we are going to be left with the limit as h approaches 0 of negative h over 4 plus 2h all over h. And now again, I'm going to rewrite the h in the denominator as h over 1. Okay. And this is so that we can use the trick that we learned in the previous video. So still the limit as h approaches 0. We are going to keep the top function as is. So that's going to be negative h over 4 plus 2h. We are going to change that division, which is represented by the fraction, to multiplication. And then we are going to flip the fraction in the denominator, right? Remember, keep, change, flip. And what this is going to do is that it is going to allow us to cancel out the h's. I mean, this is the correct way for dividing two fractions. You end up multiplying by the reciprocal of the fraction in the denominator. And at the same time, we are also going to be able to cancel out those h's, which are the problems here, right? And so this is going to be equal to the limit as h approaches 0 of -1 over 4 plus 2h. And now we are able to evaluate this limit, right? So this is going to be equal to -1 over 4 plus 2 times 0, which is just going to give us -1 over 4. And that is the slope of the tangent, or the instantaneous rate of change at the point 2, 1/2 for the function 1 over x. Right. I do have one more example for you. So we have looked at polynomials where we had to use factoring. We have looked at rational functions where we've had to use common denominators. So now all we are missing is, of course, radical functions where we are going to have to use rationalization, okay? So here again, let's take a look at the function that we are given. We are given the function f of x, which is equal to the square root of x. And we have the point 9, 3, so that tells us that f of 9 is equal to 3. Again, let's start by writing out the first principles formula. So we have that the slope of the tangent, which I am representing with an m, is equal to the limit of, as h approaches 0, of f of 9 plus h minus f of 9, right? Because in this case, 9 is my a value, all over h. And so this is going to be equal to the limit as h approaches 0 of the square root of 9 plus h minus the square root of 9, or just 3, right? That's f of 9, all over h. And so now here, in order to evaluate this limit, I do have to get rid of this square root. And to do that, I am going to use rationalization. Now, to use rationalization, I need to find the conjugate of the numerator. And the conjugate of the numerator, of course, is just going to be the same thing, but with a different sign. So we are going to have 9 plus h under the square root plus 3. And of course, we are going to be multiplying and dividing by the same amount so that we are actually not affecting the value of the expression. This is the same as multiplying by 1. Okay, remember that we are not actually changing the value of the expression. We're just changing the way it looks. Okay, so let's just compute this amount here. And in order to do that, we can use distributive property, or we can just use our knowledge of a difference of squares, right? So with a difference of squares, we are going to have a minus b squared, right? And so that's going to give us the square root of 9 plus h times the square root of 9 plus h. And that's going to just give us 9 plus h. Okay. And then, of course, the middle terms, we know that they would cancel out. And then we would have negative 3 times positive 3, which is going to be equal to negative 9. And here we don't really need those brackets. Of course, if you want to, you could also use a distributive property in this case, whatever you are most comfortable with. And then you can just simply cancel out the middle terms. Okay, and over here we would have h times the square root of 9 plus h plus 3. All right, so that's what we are going to end up with. And of course, immediately we are able to cancel out the positive 9 with the negative 9. And that is going to give us a limit as h approaches 0 of h over h times the square root of 9 plus h plus 3. So then at this stage, we can also cancel out those two h's. And this is going to result in 1, the limit as h approaches 0 of 1 over 9 plus h under the square root plus 3. And now we are able to evaluate the limit by substituting h with 0. So that is going to give us 1 over the square root of 9 plus 0 plus 3. And of course, that's going to be equal to 1 over 6. The square root of 9 is just 3. 3 plus 3 gives us 6. And this is going to be equal to the slope of the tangent, or the instantaneous rate of change of the square root of x at the point 9, 3. And this is all I have for you today. I hope that you have found this video to be helpful. If you did, please give it a like, please subscribe and turn on the notification so that you don't miss any future videos. And if you have any questions, please leave them in the comments below. Bye. I'll see you in the next one.